Okay. So we've been studying motion, and you can express that, and you can certainly write about it. You can demonstrate it physically. You can do math problems. But you can also graph it. So we're going to graph examples of forward motion. And there's going to be basically 3 different types of motion. Sitting still, so 0 velocity. Constant velocity. And acceleration. So those are the 3 types of, and I'm talking about forward motion, which means we'll probably also look at backward motion. We're going to do this on 3 different types of graphs. Distance versus time. Time is always on the horizontal. Velocity versus time. And acceleration versus time. So we'll go ahead and set this up, and then I'll wait and let you catch up with me. So imagine an object at rest, and we want to graph it on a distance versus time axis. Well, time will continue to march on, and if the object starts at this position, I don't know, let's say it's 2 meters in the positive direction beyond the origin being 0, 0, right? It'll just stay there. So as time goes on, yep, there's really not a whole lot going on the graph other than time, right? So it'll be a horizontal line. If I pick a different position, starting position, again, 0 slope, horizontal line, and where that horizontal line lives, that just tells you what position the object is in, okay? Now, if it's sitting still, what's the number value for the velocity? 0. So start at 0, and then a little bit later, it's still sitting still. What's the number value for the velocity? 0, and so on. So it's just going to remain, this graph will remain on the x-axis, right? And if it's sitting still, is it accelerating? Nope. So also 0. Okay. That was a good, easy way to start, right? Now we're going to look at an object that has a constant velocity. So that's like setting the cruise control on your car. The velocity will remain the same, and we're going to start at 0, 0, but we really could move this graph anywhere. And if we went, let's say, a couple centimeters in a second, and then a couple more centimeters in a second, and then a couple more centimeters. See, as long as it's constant, the line will have a nice constant slope, okay? And if the slope is less steep, what does that tell you about the speed?
Slower.
Right, yeah, exactly. So the steeper the slope, the faster the velocity, the lower the slope, the slower. On a velocity graph, constant velocity then takes on just like, this is really like saying constant distance. So it will take on that horizontal or 0 slope character. And if it's slower, it'll just be lower down on the y-axis. So faster and slower. And if an object is moving with a constant velocity, is it accelerating? No. Now, I am taping this, so if you want to just kind of relax and then look this up on mine a little bit later, you know, you're fine to do that. Whatever your style, whatever works for you. All right, now we're going to do acceleration. And acceleration, we'll start with the velocity graph. We're going to have a nice constant acceleration. So a little bit faster in the first second, the same amount faster in the second second, the same amount faster. And what will this look like when we connect the dots? A nice straight line. Okay? And the slope of that line, change in velocity over change in time, change in velocity over time, the slope is the acceleration. Okay? If it's accelerating and it's a nice constant straight line, what will this graph look like? Horizontal, right? Straight horizontal line. But then this gets a little tricky. We talked about this a little bit already. In the first second, yeah, not going very fast, right? In the second second, ooh, a little faster, a little steeper slope, right? In the third second, quite a bit faster, and so on. And as you cover more distance in the same amount of time, you end up with a changing slope. Okay? Why is it straight and not curvy? Because we have said this is a constant acceleration. So it means the change in velocity is not changing. It's not a changing change, it's a constant change. Does that kind of make sense? So like let's say that the acceleration is we're going to get in our car, we're going to increase our speed 10 miles per hour every second. So after 1 second, 10, 2 seconds, 20, 3 seconds, 30. But it's a constant change. We're going to add 10 every time. If it was like 10 and then 50 and then, you know what I mean, it would be a non-constant. We're not going to do that in this class. Okay, so that's that for forward motion. Oh, mashed potato bowl. Carry on. I understand.
I don't understand the first one, the sitting still with time, but
Well, this is two examples of sitting still, so there's two different lines. Sitting still just means, like, imagine the number line right here, and I'm at like 2 meters, right at this spot. Okay? So if this is the 2 meter spot, I'm gonna have to, time goes on, but the object doesn't change its position. No, S is distance. There we go. There it is. Yeah. If it's just, does that make sense now? Good. All right. Okay. So that was an easy introduction. Now we're going to get a little trickier.